Hey everyone, welcome to my channel. Today I am going to discuss about chromatography. What is chromatography? Chromatography is the simple process of separating the mixture of component into the individual component. Its complete definition is chromatography is an analytical technique commonly used for separating a mixture of chemical substances into its individual components. In simple terms, we can say that chromatography is the process of separating the mixture of component into the individual component. If detector is also connected with the chromatography column, then quantitative and qualitative analysis of separated component occur, otherwise not. Let's look about the component of the chromatography. Column. It is the hollow cylindrical structure which consists the stationary phase, mobile phase or carrier. It is the solvent or gas that carries the sample mixture with it as it moves down the stationary phase. Mobile phase actually helps to move the sample component down the stationary phase or adsorbent. It is the substance that remains fixed inside the column, and in the stationary phase the separation of the sample component occurs. Elution. The process in which sample component move down the mobile phase is called the elution. Let's look in this picture. The outer structure this is known as a column. This column is holding this stationary phase. It is just the vessel that holds the stationary phase. We keep the sample mixture at the top of the column, and once we run the mobile phase in the column, then the separation of the sample mixture into the individual components occurs. Let's look about the principle of separation of different components in the chromatography. How the separation of the sample occur in the chromatography, or you can say how the separation of the sample component occur in this stationary phase. Separation of different components of mixture in chromatography is based on the affinity of the component for the stationary phase and the mobile phase. The separation in the chromatography is based on the affinity of the component for the stationary phase and the mobile phase. If the affinity of the component is high for the mobile phase, then it spends more time in the mobile phase and elutes out faster in comparison to those having more affinity with the stationary phase, and vice versa. For example, we have sample having red and the yellow component. From the figure, we can see that red component have more affinity to the stationary phase than the yellow component. So, yellow component move out first and red component move out from the column later. Thus, we achieve the separation of the red and the yellow component from the sample mixture. We can look in this picture. The sample mixture consists the red and the yellow component. Since the red component have higher affinity to the stationary phase, it remains in the stationary phase for a longer period of the time, and yellow component have lower affinity to the stationary phase, or we can say that yellow component have more affinity to the mobile phase, so it move along with the mobile phase fast. So here we can see that first the yellow component gets separated out, and then only after some period of the time the red component get separated out. So the separation of the component of the mixture occur here. How to determine affinity of the component? How to determine which component of the sample mixture have more affinity to the stationary phase and which component have more affinity to the mobile phase? It follows the principle of like deserves like. That means if the nature of the component is similar to that stationary phase, it spends more time in the stationary phase. And if the nature is similar to the mobile phase, it spends more time in the mobile phase. Nature here means polarity. If the sample component is of same polarity as that of the stationary phase, then it spends more time with that stationary phase, or if the sample component is of same polarity as that of the mobile phase, then it spends more time of the more time in the mobile phase and get eluted out first. Those sample components which spend more time or which have more affinity with the mobile phase get eluted out first. For example, if our component is polar in nature and the stationary phase is also polar and mobile phase is non-polar, then the component is spend more time in the stationary phase. What if all three are polar in nature? Then the polar component spend more time in that phase which is more polar in nature. For example, if stationary phase is more polar than the mobile phase, then our polar component spend more time in the stationary phase. Or if the mobile phase is more polar than the stationary phase, then the polar component spend more time in the mobile phase. Spending more time in the mobile phase means it gets eluted out first. Types of the chromatography based on the polarity of the stationary phase and the mobile phase. There are two types of the chromatography based on the polarity of the stationary and the mobile phase. They are normal phase chromatography and the reverse phase chromatography. In normal phase, stationary phase is comparatively more polar than the mobile phase. In the reverse phase, the reverse of the normal phase chromatography is seen. That is, stationary phase is comparatively less polar than the mobile phase. Here the term comparatively is very important. For example, we have the stationary phase and the mobile phase. Both are polar in nature. If the stationary phase is comparatively more polar than the polar mobile phase, then it is normal phase chromatography. If the mobile phase is more polar than the polar stationary phase, then it is the reverse phase chromatography. So the term comparatively is very important here. Based on the nature of the mobile phase, there are two types of the chromatography: liquid chromatography and the gas chromatography. If the mobile phase is liquid, then it is called liquid chromatography. If the mobile phase is gas, then it is called the gas chromatography. Types of the chromatography based on the bed of the stationary phase. Bed of the stationary phase means where the stationary phase is lying. If the stationary phase is lying in the column, then it is known as a column chromatography. Like in this picture, the stationary phase is lying inside the column. It is known as a column chromatography. If the stationary phase is lying in the plane structure like the paper, then it is known as a planar chromatography. For example, TLC. In the TLC, the stationary phase is lying in the plain glass slide. Types of the chromatography based on the separation mechanism. Based on the mechanism of the separation, there are following type of the chromatography: affinity, ion exchange, ion pair, adsorption, size exclusion. Here, based on the nature of the mobile phase, normal phase chromatography can be liquid or the gas chromatography. And based on the stationary phase bed, normal phase chromatography can be planar of the column. And based on mechanism of separation, it can be affinity, ion exchange or ion pair, and so on. So we can say one chromatography type is not distinctly different from the other. For example, the column chromatography can be affinity, ion exchange, ion pair, adsorption, size exclusion based on the separation mechanism. And so for the planar chromatography, based on the separation mechanism, planar chromatography can be all this type. Thank you. This was for today.